This is the Math Map Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known. So, welcome to the Math Map Book Club. Today is Wednesday, October 1st, 2025. I can't believe I'm saying that. But this is where Dr. Kirsty Gilpin and myself and our regular math moms get together to talk about the Math Map curriculum used by families enrolled in Classical Conversations. And every time we do this, I listen to our little jingle, and I still think it's the right jingle at the opening. We're just ordinary parents trying our best to help one another. So anybody's welcome. So Kirsty, thank you for making it so approachable as you moderate and teach us.
Well, all glory for that to the Holy Spirit, because I just trust that He is going to speak through me. So I try to leave plenty of room for Him. And it's a great reminder because we're talking about lesson 10 and intersected lines. And so one of our favorite intersections is that intersection of the divine with the earthly, right? With the temporal, that happened in Christ. And so He, through His sacrifice, and then because He went back, right? We were talking about this in our Bible study last week, that we would all really love, we all think it would be great if Jesus still was here in 3D with us. But if He was, there would be one of Him, and there would be so many of us that we would be fighting over, like, no, He's coming to my house, right? And you'd get like a couple of minutes and He'd be like, nope, sorry, I'm off to see Babs now. So He left and gave us the Holy Spirit, who is everywhere. And so it occurred to me, right, that having this dimensional language helps us to appreciate, right, what is a limitation of 3D, right, that Christ could only be in one place at a time, that's removed when we think of the fourth dimension or more dimensions, that the Holy Spirit can be with us, right, all at the same time, that He can be present with us, and we don't have to fight over who gets the Holy Spirit today. So anyway, that is a completely off topic a little bit, but just a thought that popped into my head. So as we start every week, we think about strategies for flashcards, and we're sort of going back through the list now. So we talked again about how reading the flashcards is a great strategy. Not only is it a great strategy for introducing the flashcards, but also going back and independently reviewing them. Sometimes we may think we know something, and when we go back and we attend to it and read it carefully, we may see something we've missed before. Last week, yay Jana, because she shared with us her system for practicing, which also allows us to celebrate, right? As those cards graduate, we can celebrate our growing knowledge. And then this week, we're talking about how we can mix up our decks again. And so what are some things that you could do if you wanted to customize your practice deck? You could look for related cards. So for example, you might pull out some notation cards that have to do with fractions and the fractions notations and compare those, or notations for roots, right? Or a perfect ones to add together are the exponents with the roots and the logs, right? So these sets really go together because we know, because we've been through week 7, we know that exponents, roots, and logs, powers, bases, and indices, they go together in a 3-part relationship, right? So with our addition deck, we can practice addition and subtraction, right? By knowing our addition facts, we can see the subtraction facts. We can practice division using our multiplication deck by, again, seeing the inverse. But with exponents, roots, and logarithms, we really kind of need these 2 decks for us to explore all 3 parts of that relationship. So those are a great example of where you may want to mix your decks to put some like pieces together. Um, or you could choose a set number. You might say every week I'm going to have, um, you know, 5 challenge cards, right? The ones that are new that we are struggling with, those might be our challenge cards. Our developing cards, the ones that we mostly get, right? And then our mastered cards. So maybe you pick a number of cards and maybe let your students pick which cards fit into those categories to build a practice deck each week. So lots of different ways that we can customize our our flashcard deck in order to practice our flashcards. Anybody have anything they'd like to share about flashcards?
When the exponents deck came out, I pulled out just a select number of those. Like I got 8 cubed and 8 squared and 8 to the 1/2 power of 8 and the one anyway, and I just had like maybe, backs and fronts of those 4 cards or whatever. And so we got used to like what does it actually mean when there is a negative exponent? What happens to 8 when I have a negative exponent? Or what about when it's broken? So we became familiar with the concept with just a few of the cards, and now and then added more in. That seemed easier to find the pattern, maybe, instead of just rote memorization for my son. Anyway, that worked.
Yeah, I really appreciate you saying that because for our younger students, right, rote memorization may be great, right? They may not need to understand what that 1/2 exponent means. They can just memorize that the 1/2 power of 8 is 2 square roots of 2. Right? They can memorize that and not understand it. But for our older students, the flashcards can represent another way of looking for patterns because we can lay them out and say, what pattern do you notice? What's happening on all of these? So I really like that idea that we can use our flashcards in different ways depending on the age and the level of our students. That's great. On our first day of the week, we like to take our time to look at our covers, our beautiful works of art, and we are back around to using our core habits. So as we look at our cover with our core habits, right, we want to emphasize that naming is using accurate words to identify familiar objects. For me, that was really how I've always thought about naming, is that with our youngest children or our dogs, right? So let's be real. I just recently adopted a dog, and what do? We take her out and we use baby talk, right? She's an 8 to 10-year-old dog. She's an adult, but we still use baby talk, right? And what do we do with babies? We ittle bitty and we use silly words because they're fun, right? And they're engaging. But as our children age, we don't want to stay there, right? We may with our dog because she's a dog, but with our children, we don't want to stay with baby talk. And we really want to help them to build their vocabulary by using accurate words. And so when we look at a piece of art, right, we could go, well, there's a couple of crossed lines. Well, it would be better to say intersected lines, right? Or right, what's happening in this picture, and to use as many accurate words as we can, right? So, well, it looks like there's a thing on his head. Well, it's called a turban, right? So this is a way that we can help our students to build their vocabulary by using those accurate words. We can attend by finding an example of the title in the art, the quotation, or the reflection. So asking our students to look at the title, right, intersected lines. Do they see any intersected lines in the art? Or if we look at the quotation, we see that the word intersection, right, is in the quotation. In our reflection, we see that the word cross and crossroads is there. And so we may link the idea of cross and crossroads with intersections. And so there's a way we can attend by picking out those specific words. We can practice those consistent pairs on the page, right? And so when I say that, right, we've talked about this now for a couple of weeks, right? That up in this top left-hand corner, there's always the dimension and the dimension image. So helping your students to memorize that, or to memorize the number and the title of the lesson. As we build familiarity with the charts, it's going to help our students if they know what number goes with what concept or what title. There's always our art, title, and author, right? So there's some pairs of information. Oh, and don't forget your domain over here on the left and the number set. So we see here that every week we have these pairs that we can be working on memorizing the things that go together. We can express by praying the reflection together. So sometimes our reflection is less of a prayer, and sometimes it's very obviously a prayer. And so here we see, right, it says, Lord Jesus, may you always be throughout my life a constant companion. May the cross which rises at the crossroads be for me like the meeting of a friend. So that can be uttered as a prayer. So we can express that by praying together. And then our storytelling, some prompts for our storytelling might be, what's the setting and who are the characters? In this case, it's very clearly depicting a Bible story. So it's an opportunity to pull from your students' memoria, right? Or maybe go and actually read a story from scripture that would go along with this art. Anybody have any questions about our core habits and our covers?
I want to say, Kirsty, it's the first time I've heard you in a while. We talk about memorizing lesson title with a number. And for, because you and I have done that because we've been working on this thing for so long. But I just want parents to realize that that all by itself is actually the map. And if you had that map memorized and nothing else in our lessons, but you went on to college and started taking some math courses, if you could actually fit in, what you were learning in your math courses and say, oh, we would learn about straight lines before we would learn about curved lines. That would probably be in the math map in this section. Like even now, as we're working on writing it and answering people's questions and teaching with our own children, for those who are, that order is helping the adult in the room know how math fits together. So I just wanted to remind folks that what I thought what you just said was really important.
And I know when I kind of realized when I would use the term math map
Mhm.
and people think different things, like really it's that page, it's the second page of every booklet, it's the name of the curriculum, and it's also the concept of all of this. And, so yeah, that's helpful to know.
It is. Thank you.
I think that just piggybacking off this conversation, even just this morning when we were working through it, we're struggling with significant digits. And so we were talking about when would significant digits have been initially introduced? And we actually worked backwards using the I-1 page, trying to figure out which chart we should go back to look at it. And we were able to figure it out based on what domain we thought it might be introduced in. And we turned out to be right. So, well, wrong once, and then we talked about it again, and we turned out to be right. And just us knowing the order of the domains was very helpful in trying to figure out where to go find what we needed to look for the answer.
Thanks, Nicole. That's great. It's just like the kids in our CC students go on to college and a professor will say some history fact and somebody starts singing one of the songs. I can see our students in 15 years, notice how long, 15 years, being at college and saying to the professor, where's that on the map?
Yeah, for sure.
Great conversation. So of course, every week we're encourage you, right, as Jana said, to look at the map itself, right? Where are we in the curriculum? And also where are we mathematically, right? So we're in 2D, so we're looking at 2D ideas. And so having that conversation, right, it can be, let's face it, some weeks this may be, okay, just check the box, where are we? And other weeks it may be an opportunity for conversation, right? Where, right, if you're in monomials, what kind of numbers should you be familiar with? What kinds of things do you have to look forward to? If you're in integers, what kinds of numbers should you be familiar with? What kinds of numbers have we not operated with yet? What are coming up? Where are we, right? If we're in 2D, what does that tell us, right? Compared to 1D. So depending on the age of your student, depending on the number of years you've been in the math map, there's all kinds of opportunities for conversations just on this page alone.
Can I ask one question about it?
Yeah.
Can you give me language around this? One of my kids is struggling with the difference between fractions, decimals, and rationals. And I just need language around how to explain that they're all rational numbers. I mean, I just say they're all rational numbers to him, but he's just really wrestling with how do I know which one to write down?
So when we think of number sets, we're always, I'm going to change my color here or turn on the highlighter maybe. When we think of number sets, we're always going to look for this row along the top. So those are our number sets. The words that are below that are the math map domains. So if I'm looking at digits, they are part of that naturals number set, right? They
Mhm.
are also integers, also rationals, also reals, also complex. When we look at decimals, fractions, and rationals, rationals is our number set. Decimals and fractions are different expressions of rationals. So we're almost always really going to be talking about the rationals in terms of a number set. Whereas if I said I just want to look at fractions or just want to look at decimal expressions, those are expressions of rational numbers.
And when you say domain, is it not when there is a difference between domain and number set?
Well, no. Well, yes. So a number set is a globally recognized set of numbers, right? That really wherever you go in the world, if you're talking math, everybody's going to say, we know what the naturals, the integers, the rationals, the irrationals, the reals, and the complex numbers are, right? We all know what those are. It doesn't really matter where you are. Some people might include zero in the naturals, some people might not. Um, but everybody pretty much knows that those are our major number sets.
Mhm.
When I say domain, I'm really talking about what numbers am I using in this case, right? What numbers are being used as my input or as my operands? And so when I say what's the domain of this operation, I'm saying what kinds of numbers am I using? Now, I might say they're all natural numbers. Now that number set has become my domain. Right?
Gotcha.
A domain can be more limited because I could say I only want even natural numbers. Right? I can limit it, or I could say I
Okay.
only want integers between -7 and +3. So I can have the domain can be more limited. So those number sets are this sort of a global definition, but we often use them to describe the domain of an operation or a function.
Got it. Okay. Thank you.
You're welcome. That's a good question. So moving on to our lesson pages, as you can see, we're talking about a lot of different strategies for our lesson pages because we really want families to remember that it's a smorgasbord, right? I think Rachel, I don't know if she's on our call today, but I saw a post that she had and she said, remember that your curriculum is a menu, right? It's not a checklist of things you have to do. It's this menu of things you can pick from. And so our lesson pages are similar. Some families may start on day 1 and work to page 16, and that works for them. But we really want families to be encouraged that there's not a right way. that there's a lot of information here for you to be able to tailor to your student, to your family, to your season of life, tailor by lesson, tailor by dimension, right? There's so many different ways that we can tailor the curriculum to make sure that we're meeting the needs of our students and to make sure that we're making progress towards the goals that we set for math education in our home. And I say that intentionally because we haven't said it recently, right? That the first thing that you really need to do when you're looking at your math education in your home is make sure you know what your goals are. And don't let the world pick your goals for you. And I think that probably most of us, that's how math education happened in our home. That it was either, oh, I know I'm going to do a standardized test, or I want my kid to get into college, or, right, the world says I should have done calculus by 17, whatever it is. You can hear all of that, but then pray and say, this is what our goal is in our home. And remember the wisdom that I always credit Lee with saying this, right? That if we're shooting to know God through mathematics, if we're looking for that ultimate, right? We're shooting for Christ, all the other things are going to be taken care of, right? And so if you haven't taken time to make goals for your homeschool, for your family, for math education in your home, I really encourage you to stop and say, what is it that our goal is for this year or for this lesson, right? We can have intermediate goals. And once we know what those goals are, we can pick and choose from these strategies to meet those goals. And so one of the things that we can do is begin by having the students find the familiar grammar on the pages. We've talked quite a bit last year about familiar and unfamiliar. We've used those words less this year. So I wanted to bring that in and remind you that for your students to look at their lesson pages, which sometimes can feel overwhelming, right? Whether it's the math map or Saxon or some other curriculum or a science curriculum or even, right, a new book that they might be reading that's really thick. Whatever it is that we look at, sometimes we can be overwhelmed. And the best way to combat that is to say, well, where can you rest? What is familiar? And so looking at a page and saying, what's familiar on this page? And it may not have anything to do with the math. It may be that by week 10, they've started to recognize, hey, the tops of the pages, right? Always have the number and the title and my domain and a title of the chart. And oh, on one of them, there's always a flashcard, right? So maybe I just rest in knowing where that page fits in, right? Maybe I recognize that there's always these other bars, these lighter colored bars that give me some hint as to what I'm doing and how that section matches to other domains. Or it might be mathematical things that are familiar. I might say, oh, this looks like a clock. I'm familiar with the clock. I know how to tell time. Right? Or I'm familiar with this idea of perpendicular and parallel because we talked about it last week. So start the day by having your students find the things that are familiar so that they can rest in what's familiar and build their new knowledge on top of that. Any questions about strategies for lesson pages? So looking at our page 1 lesson pages here, are there any questions about any of the concepts or the math that's on these pages?
Kirsty, would this be a good time to talk about what we discussed yesterday? It's not exactly the same problem, but that these angle measures at the bottom, that you have the angle measures referring to the degree around or the radians around versus the actual length of the arc. So I maybe look at monomials because it's got some nice arcs at the bottom and some angles.
Sure. So it's actually a really great progression because in this case, right, we're just looking at angles. And so helping our students to work through this idea of rotations and angles is going to help them to differentiate when we get to circles, the difference between, right, what's my rotation around versus my length around, because we're going to talk about that when we talk about circles, right? That there's a difference between 360 degrees in a circle or how far around is my circle, right? What would be its linear measure?
Yeah,
And
so
then
because I
arc
want to
length.
share like so Chrissy just totally confused me with that, and afterwards I was thinking, why was I so confused? That's so basic. And I realized it was because I was trying to make everything fit on a page. And that's not quite how it works. So I might go through a 15-degree angle, but if it's traveling from my Walmart to Raleigh, that length's going to be really long. But if it's on my page, I was like just looking at and trying to figure out how is that not just my measure? Why do you keep saying there's a length to it? Like my brain couldn't understand what your words were saying. And I think that happens to our children a lot.
It does. So this is a great opportunity to really rest and camp in the idea of not length, but rotation, right? That our angles are a measure of rotation. And so and just a quick note, especially for those of you who are astronomers and scientists, and you want to see a clear delineation between rotation and revolution. In math, we use them interchangeably. In science, they have two separate meanings. So you may see that there will be times where we talk about revolution, and sometimes we might say rotation, and they mean the same thing when we're in mathematics. So when we're thinking about angles, and this lesson is a lot about angles, we're always talking about what is the rotation, right? What is the rotation from one point to another? And notice, right, when we think about that, right, if you use your elbow with your student, right? Your elbow is kind of can be your turning point, right? We have to have a vertex where that rotation is centered. And so you just use your arm to help them see. It's not how far is this traveling, it's how much is it rotating, right? And so it doesn't matter whether at what point I look at, right? So think about it with your arm, right? You can say, okay, I happen to have a good shirt because I've got, coordinates on my shirt. But you could say, look at all of these different points, right? It doesn't matter which point I'm looking at, the rotation is always going to be the same. And so that helps them to see when we draw an angle, it doesn't matter how far the sides go out, right? They could be here or they can be here. It's the rotation, not the length. And so and just even understanding that for angles is going to carry over to this idea of arc length versus arc measure, right? Helping them to see that we're talking about rotation. I always think it's neat that God gave us these bodies, that we can actually use our bodies to explore these math ideas, right? We don't need anything external. He gave us what we need right here. You can even do it with fingers, right? So if you say make an angle with your fingers, right? No matter which points on my fingers, the angle doesn't change, right? You can actually see it. The angle doesn't change if I look at these 2 points or these 2 points or these 2 points, right? That's what we're measuring is this angle. So any other questions from day one? On day two, we like to take a look at our I² invention page. And remember that this is not, although there's a lot of good math and many people find these pages to be very helpful from a math perspective, especially with our younger learners, remember that our goal here is to use this to practice our common topics of invention. And so when we think about practicing our common topics, we can look at the page holistically. We can consider the math that's on the page, but we can also just look at the page itself. And so when we look at a page and we're thinking about relationship, right, we can think about order and we can think about cause and effect. So when we look, we could say, are there any ordered lists on the page? This page doesn't seem to have any ordered lists where they're numbered, right? But sometimes we see that there's these lists that are in order, in a specific order, and we might want to remember that specific order. Are there numbers in order on the page? In this case, we might come down here and notice that this seems to be in order. Right? And that order matters when we look at this. Right? Because if I change the order on the left, then I would have to change those equations on the right. So that order matters. So talking about, okay, well, what order do these go in? Is there a process or an algorithm listed on the page, right? Things that are a process or an algorithm are usually steps, whether they're numbered or not, right? Once they're given in steps, right? We know we have to do something before we do something else. So we can look for processes or algorithms to look for examples of relationship. And we can look for examples of cause and effect. So I think one of my favorite examples of cause and effect is the independent and dependent variables, right? Because the value of X is going to cause the value of Y, right? Y depends on X. I pick X first and then I get Y. So there's a cause and effect relationship between my X and my Y, right? So you might look for either examples or of those variables, or you might look for equations where one value determines another, right? So if we look here, I see that the sum of two angles is 90 degrees. If I know one angle, that's going to cause the value of its complement, right? In a sense. So when we're trying to help our students to play with this idea of relationship, those are some ways that we can say, okay, well, if, right? And we see it here, right, with if thens and if and only ifs, or therefores or such that's, right? Those are all some symbols that are going to hint, right? If one angle is 30, then its complement is 60. We see that if then. The if is my cause and the then is my effect. So those are some things that we can look for to practice relationship. Any questions? All right. Any questions from our two set, page 2 exercises? I always think it's a shame that this lesson isn't in February, because it would just fit all of those fun Valentine ideas so well, right? Where you talk about acute angles. Maybe I'm the only one that used to really look for the math Valentines. All right. On day 3, we like to practice our skills that are related to memoria and also look at arrangement. So remember, our flashcards are really primarily looking at loading the grammar out of context. And so Jana gave us a great example of where we're looking at it in context, and we can use our flashcards in that way. But when we're just drilling our flashcards, we're loading grammar and it's usually out of context, right? We don't always see the pattern. We're just loading the grammar. This page takes that grammar and puts it into context. It's going to take that grammar and order it. And so when we use our core habits to study that arrangement, one of the things we can do is we can attend. And we've talked about this before, but this is a big skill, especially for our younger learners, being able to match rows and columns to find a cell. So you could almost play bingo, right? I'm going to call out a column and a row, and then you mark off what you have there, right? So counterclockwise. So now I know that I'm in this column. and straight. So if I said, what's a straight angle that is in radians counterclockwise and it's a straight angle, right? Your student could say, oh, well, that's pi, right? Not because we're necessarily right practicing all of those things, but we're primarily practicing find revolutions, find clockwise, now match that to the right angle, right? And we get -3/4. So just helping them to see, how do I match rows and columns?
Mm-hmm.
Or you could start with the cell and ask them to read the headings, right? You could say, okay, I want you to find -√3/3. And there's 2, right? So they find them and you say, okay, well, where are they? What are they? Well, they both are here for the slope of the terminal side. One is in obtuse and the other is in reflex. So going both ways is a great way to have your students attend and practice just reading a table.
So, Kirsty, I love this bingo idea and this reading idea you've given us. I mean, I just have to show Trey 2 different examples, and then he'll be like, "Give it to me, Nana," and he'll say, "I'm stumping you." And having them lead the conversation is so much better than having us lead the conversation. So anything you can gamify, I think is a great idea. So I had not thought of that. Thank you.
Of course, attending can always mean reading, right? Reading the notations and abbreviations. So especially in this case, right, we have a lot of abbreviations. So we want to attend to those and know what they mean, right? We have a lot of notations, right? So being able to read those and understand what they mean. We can look for words or concepts that are familiar, right? So again, reinforcing this idea of a page full of information. How do we find things that are familiar? And then, especially as our students are gaining familiarity, we can ask them to look for patterns. How do things change in a row or a column? Are there repeated elements? What goes together? Right? What's different? So in this case, we might say, well, look, as I look at my degrees, I added 30, 15, 15, and 30. Okay. Oh, 30, 15, 15, and 30. 30, 15, 15, and 30. Right. And so I start to notice this pattern as I'm going down. Right. And okay, so there's a pattern there. I may not know why, but I'm seeing a pattern. Or I might know as I go through a row, right, that there are some things that go together, like 30 and -3/30. Well, if I made that one positive, together they'd be 360 degrees, right? That might be something worth noting, right? That the sum of the absolute values is 360 degrees. Or again, right here, I might notice I've got 1/12 and -1/12. Well, actually, this whole column is positive and this whole column is negative, but their absolute values are going in the opposite order. So depending on our students, right, and every year there's a different thing to look for, but those are some ways that we can attend. Even with our older students, right, we may start to think, oh, those core habits, right, we're beyond that, but we never are, right? No matter how old we are, attending is really, really important. Right. Attending is really, really important because we want to look and we want to say, what do these things mean? I don't want to just assume that I know. I want to attend. Just like when you read scripture, right? How many times have you read the same piece of scripture and you think you know what it means? And then one day you attend to it a little bit differently and you get a whole new insight. So, any questions from page 3 of lesson 10? I always think this lesson is a really great lesson if you feel like you need some additional practice for addition. This is a great lesson because you can practice adding angles. You can practice explementary, supplementary, and complementary angles, and you can just give your students all kinds of different measures. You don't have to use just the ones that are here. And so there's a great way to bring in addition practice while also practicing the concepts.
On the monomials page there, in the top box where it has the linear, it has the slope-intercept form written under the line with the positive slope. Just like looking at that other, the one with the negative slope, that looks unfamiliar to me with the x being divided by m, and I can't think why it would be written that way.
Well, I think that it was written that way just for space, but you might be more familiar if it was -1 over m times x. Then it would feel more familiar to you.
Because m and when they're perpendicular, m
Yes.
of one
It's
is
a
equal to
reciprocal.
-1 over m of the other.
Yes, okay.
Mhm.
Yeah, it's because of the relationship of
Yeah.
perpendicularity that, okay, right. Thank you.
See? Attending. There's all these details.
When my kids get stuck on something like that, um, I struggle with finding where to lead them versus didactically teaching them. Um, and I don't know what else to say about that. Just thought I would say that.
I
think
don't
it's
think
a
you're alone in
no, you're
that.
not alone.
Ditto.
Because it's easier, right? We all are like, I understand, let me tell you how it works, right? I
Mhm.
mean, I do that when you guys ask me questions, right? Because it's
Mhm.
easier. It's easier just to tell you. It's a lot harder to wrestle, right?
Mhm.
Um, and it's not just about math, right? It it's a lot easier to tell than to ask,
The
right?
other thing is, I mean, this is why, because we do have ordered learning here. I'm not contradicting what Kirsty said earlier. It's just our order is different than most books. Our order is that we're looking at these things and dimensionality, and we're expecting you to read and look at the page before we expect you to calculate. Those are two of our orders. So another thing that we do is when our mind isn't orderly, and like, you look at your kid and say, I don't know, explain that to you. You can say, let's pray, or let's go play basketball, or let's go get a snack, or let's rest and we'll do it tomorrow. But it's this idea that, and that's where Kirsty's right. You have time to try it again a different way the next day or in 20 minutes to think about. Give yourself time to think instead of it's always chug and plug, chug and plug, chug and plug. We're just not doing that. We're trying to break that habit.
Yeah.
Mhm. So, good question.
I think too, well, this is just me personally, I guess, I'm very structured as far as time. So I want to do this in a certain time. So what you just said is going to blow that out of the water, right? Because I've already said we're going to sit down here for an hour. And now we got stuck. And so now in my mind, I'm like, but we have to do it right now because in 20 minutes, I have something else for us to do, right? So being flexible, I think too, is a big key, which is a part of parenting, right? You can't always be structured if you have children because that just doesn't work. But I think that's hard to do too, is when you're trying to say, well, this is how I want it to go. It doesn't go that way. And so now I've got to go a different route, right? And that's frustrating. But if you think about the end result, okay, let's go get a snack and come back. And now my brain is has switched, right? And now it's a little bit clearer because now I have a snack in my belly and I'm not irritable because I was hungry or whatever the case may be. Maybe I ran outside, ran around the yard and that helped. So just kind of changing perspective.
And we had this
Well, and for
happening
me,
last. Go ahead.
I was gonna say, for me, the other part of that is I think I've given up, at least for now. I think, I've given up how much needs to get done in that hour. And I'm much more focused on, I need you to focus for 20 minutes, or we're going to do this for 15 minutes, this for 15 minutes, we're going to take a break, but I need you to focus and try to get as much done as you can, as opposed to you need to get all of this done in that hour. So some days We might get 3 or 4 pages done, but some days we'll spend 15 minutes trying to figure out significant digits. And so now we literally only got one section of one page done, but we much more thoroughly understand how to choose significant digits. And so I'm I'm working very hard on being okay with that. I cannot say that I'm there. I'm really trying. I'm trusting. It's a trust fall, guys. It's a trust fall.
But the thing is, one of the reasons we needed to do a different curriculum is because math education for the last 50 years has failed everybody except for those who are already good at math. And so having this expectation that we need to repeat the way we were trained is going to fail 85% of our students. It's going to be great for 15% of them, but it's not going to be good for 85% of them.
Yeah, I had something happen in class yesterday that illustrates this really well, because I feel like usually, like with the didactic model, I'm just picturing like trying to explain quadratic equation solutions to kids and like the zone out and like the didactic, like nobody engaging. Well, yesterday we were talking about, like, we noticed that when the graph of a quadratic equation crosses the x axis, that's where the two solutions are. I know that's super basic, but it just hadn't clicked for my students before. And so then we were talking about the discriminant, and I'm sorry, I'm using or I can't think of the word, but it tells you whether you have real answers or imaginary answers. We could not figure out what happens when the two solutions are imaginary. Where does your graph cross the x? Like, and kids were talking about it at lunch. They were talking about it after school, like, because they care about it. It's not, I wasn't instructing them how it works. They're trying to figure it out, and it's engaging and winsome and sticks with them. So
That's amazing.
Great.
And can I just add to that is that this doesn't feel like it connects, but it does. In some of the conversations that I've been having around politics, I suddenly in a flash was like, hey, I know you guys want me to be on this side or that side of this real number line, but I'm all the way on the imaginary number line, guys. I'm a kingdom kid. I'm all the way on a different number line. And it just kind of poured out of me. I didn't even like really mean to do it that way, but it was like this, that y'all trying to keep me on the real number line and the kingdom is all the way in like in a whole different
I
realm.
love that,
And
Nicole.
I loved it. It just helped me a lot in that moment because I was like, I know you want me to, but I'm just kingdom. I can't
I
help
love
it.
that. Great conversation. So moving on to day 4 is where we look at our careful calculations page. And so I'm going to be honest with you all, I have fewer ways to adapt the careful calculations pages. But one that I came up with for this week is just using it as daily computation practice extensions, right? So if in any particular day you feel like you need more computation practice, right? Maybe you had a really in-depth conversation and the lesson pages maybe still feel a little bit overwhelming, but you want them to do some calculations, right? We'll pull out that careful calculations page and go, well, what calculations on this page kind of go with what we were just talking about, right? Is there a calculation here that we could practice, right? So we can pull that out and match them to the pages where the concept was introduced or practiced, or where it is on the chart, right? Maybe we found something on the chart that was interesting and we want some calculations to match it. Pull out that careful calculations page and see if it's there. And then remember that we can use these as model problems to create additional exercises using either like cards or your own memoria, right? So for example, right, maybe converting radians to degrees, maybe you had a really great conversation about what the difference was between radians and degrees, and you want to let your kids rest there, but do a little bit more. You can say, okay, well, just go do some conversions, right? And why don't you do, right, all of those angles that were on the I3 page, right, from, right, all of those angles that we had all the way around, convert all of those to radians. And guess what? If they did that, the answer's on the I3 page and they can actually check their work. So there's a way that you can pull that careful calculations page, right, and use it daily instead of all just on day 4. And then we get to our 4 set, our page 4. Does anybody have any questions about any of the ideas here? Notice there's a lot of practice, continued practice, just right. What are names of angles? What are some measures of angles? How do we categorize angles? As our students are looking at these, they're also getting visual cues for what those categories of angles are, so that when they look at an angle, they get a sense, oh, that's acute, or that's obtuse, or that's reflex.
If you look at these 3 pages, so if you look at the integer, there's only 3 problems that have any idea of calculation, the middle section on the right. And then on the fraction page, your measures of your AM and your AP. You don't really have to do any math, you just have to read the graph. All of these are comparative words in integers and fractions. And then when you get up to monomials, you now do have some calculations. The middle of the page gives you not 1 example to compare, but 3 examples for the graph. And then the bottom has this stuff that everyone finds hard, radians and revolutions, until you do lots of them. So here's 8 radian and revolution problems right there on 1 page for them to practice. And if it gets too crowded or they're struggling, don't do it there. Go get a piece of scrap paper and do it. And then if you've been paying attention then to what Kirsty showed us in some of the other charts, there's summaries of this. You could just say to your students, we're not even doing this bottom section where it says angle type. We're going to go play a game on the frame page instead. There's so many ways to do things, but I want you to know there's some pages where there's just hardly any calculations, and there's other pages where it's all calculations, because mathematicians do both. They read and they think and they name and all the other things we've been practicing.
So that, of course, we always like to take our time at the end of our call to remind everybody of the support that is here for you, whether that's in the companion, the forums, your community, through email, and of course here. I know that we have a lot of people who aren't able to join us live, but enjoy the recordings. So I just want to give a shout out to everybody who goes and watches our recordings. And a reminder to you that if you have questions you would like to see us work through on the book club, you can email us and we will go ahead and answer those. So then when you watch the book club, you will get your answer. And I just thought I would share this picture because I have, in our neighborhood, Lee can attest to this. In our neighborhood, the deer eat everything. It doesn't matter if it's supposed to be deer resistant or not. They just eat everything. And so all of my really pretty plants I have to have up on my deck. And this rose has just exploded. Like, it's just full of blooms. And I thought it was so beautiful that I wanted to take a picture and share that with you. And not just because it was beautiful in and of itself, but just as a reminder that this is the kind of thing that you could be taking a picture of and tagging for your Seeing the Unseen booklet, right? That Seeing the Unseen doesn't have to be this hard, like, go out and really think deeply. It can be, but it can just be, oh, this was something that was so beautiful. And if I look at this, I see all kinds of things, right? I could count the petals. I can see the symmetry, right? I can look at, right, the arrangement of the leaves, right? And find symmetry within the leaves or within the arrangement of the leaves. Right? I can talk about how I encountered this with my senses, right? What would it feel like if I touched, right? If my finger intersects with the thorns, what does that feel like, right? So there's a lot of ways that we can, when we encounter beauty or goodness or truth on our walks through life, snapping a picture, making a note, and just saying, well, is there some math there? Chances are that the answer is yes. And that's how you build your Seeing the Unseen booklet. So I just thought I would share that with you because it was so pretty, but also as a reminder to be collecting those things so that when it comes to week 29, you can pull those back out and remember how you've seen God's hand in creation and in mathematics over the course of the year. Are there any questions? Did anybody bring anything they'd like to talk about at the end of our time together today?
Do you mind if I bring that back up that I was just talking about when you're graphing a parabola?
Sure.
So this is the pattern I've noticed, and the word was determinant. I was trying to say discriminant, but the determinant, that little box on the, and if anybody's listening and discouraged because they don't know this terminology, oh my goodness, 2 years ago I didn't know any of it. Like, it's literally been doing the math map and being on these calls that I can even use these words. But the determinant, if that comes out to a negative answer, then I know my two roots are going to be imaginary. And it seems like the parabola is up above the x-axis. Okay. And then if it's 0, it sits on the x-axis. So it's only touching in one point. So both of my roots are the same. And then if it's a positive number, my parabola sits below the x-axis, and the two places where it intersects are going to be my real answers. So
Yes.
is that right?
That's right.
Okay.
Although you were right, it is discriminant. Determinant is matrices. Discriminant is that b squared minus 4ac.
Okay. Okay. The discriminant.
Because it discriminates between real and imaginary.
Okay.
And what I love about Jan is you recognize there's only three choices. It's either above the line, below the line, or on the line. And so therefore you're going to see a whole lot of those three choices.
Well, I just couldn't figure out, how do you graph an imaginary number? Like, we've used that other coordinate plane, but that's not actually coordinates. It's I mean,
Christiana, what are we graphing? So when we look, right, when we look at, let me make sure my pen is turned up, right? When we're graphing x and y, what's the domain of x and what's the domain of y?
They're real numbers.
They're real numbers, right? Yep. So is there anywhere on this graph that I would see my imaginary number?
No.
No.
But you can still graph the parabola.
I can still graph the parabola, right? Because the parabola is a real versus a real, right?
Okay.
I'm going to see,
Yes.
when I look at my parabola, all right, I have a real versus a real. Now, right, this is where the intersection is between what you're thinking, right? If I say, right, y equals x squared, right? I'm saying, what are all of the values, right? For every value of x, what is x squared? That's what this is. That's what this graph is saying to me, is
Right.
here are all the squares of all the x's, right? Well, now if I was to look here, and I want my real and my imaginary, right? Where I would see those roots, right? The roots are where right, x squared equals 0, right? Well, on this side, it's where it crosses the x-axis. But
Right.
here is going to be a complex point. So I'm going to pick, I'm trying to think, let's say, I'm going to erase this and I'm going to show you, let's do this example. Let's look at, oh, sorry, let me go back. Come back. No, come back. There we go. There we go. Pen. Okay. So I have my real versus real, and I say y equals x cubed. Let's do x minus 8 cubed. Well, if I was to do this, I'm going to find that it's going to look like this. And I'm going to have a root at 8. And I can find where that point matches, right? By saying 0 equals x minus 8. And I'm gonna make this better. Bear with me. Bear with me because I'm going to make it better. I'm thinking on the fly and I'm going to make it better. And erg. Thank you for all being patient. Okay, pen. All right. Not x minus 8 cubed. Let's look at this one. That y equals x cubed minus, or x squared. Let's do squares because that'll work. X squared plus 4. Okay. If we were to graph that, you would go, okay, it's going to be up here. There's my x squared shifted up 4, right? And if we were to look at our discriminant, our a is 1, our b is 0, and our c is 4. And so my discriminant, right, I'm looking at my b squared minus 4ac, which is the square root of -16. And we have imaginary roots. And our graph is up. And we're all like, okay. So that is when I'm doing my real versus my real. And I'm looking at my input versus my output, my domain versus my range, however we want to talk about that. But now let's look at the case where y equals 0 again. In this case, 0 equals x squared plus 4. And so x squared equals -4. Right? Now, if I solve this, I'm going to get my x equals plus or minus the square root of -4, which is going to be plus or minus 2i. Now, I can take that, right? What I'm looking for, what are the two roots of -4? That's what this equation says, is that there are, right, I'm looking for the two roots,
Yes.
right, of -4. And now if I look at this in the real and the imaginary, right, in the complex plane, I have a root that's going to be at 0 plus 2i and a root that's going to be at 0 minus 2i. So that's,
Which
so
doesn't
if
look
I'm,
anything like a parabola, correct?
it doesn't look anything like a parabola because it's not, right? It's really just one solution, right? It's really just, it's looking at just the values of x that are the roots. And I can look at those and plot those in the complex plane because I'm just looking at one variable. If I'm looking at two variables, both my input and my output, my dependent and my independent, right? Then I have two variables, and now I see that all of the solutions. So this is all the solutions, right? This is every x and its square. Right, that's what that one is. This is, it's kind of like one solution, right? This is it, and I'm going to say one with quotes because we see that there's two, right? But it's looking for one solution, right? Where y equals 0. What value, right? What values give me the y equals 0? That's the relationship here, right? And so I'm looking for, right, just the roots. So there's two different grids are going to give me two different information, two different pieces of information that are related to one another, right? But they're different information. Does that help?
Yes, totally. Totally makes sense.
Sorry it took me so long to get to the right example to show that, but hopefully you can see how these ideas are related.
Yeah, I'm going
Right.
to take a picture.
So,
But
Kirsty, I want to use your words here. So when you're using the real versus real axis, you're looking at all the solutions. But when you go to real to imaginary axis, that's the place, because you have imaginary numbers, square root of -4, where you have to plot the solution, not all the solutions, but only the root
The
solutions.
roots,
Yes.
which we just learned in our week 8 booklet, the roots are where y equals 0. It's what x is when y equals 0.
Yes.
Okay. Awesome.
Right. Which means that, right, in this case, we're saying there are 2 roots of -4, and there they are.
Mhm.
Right. And so that's why we say there's like that every number has 2 square roots. Usually, when we're thinking in the reals, we just look for the principal square root, right? That's usually, if we're simplifying, we usually just want the principal square root. When we're solving, we want all of the roots, right? When we're finding the values of x that make the equation right, we want all of their roots. And then we oftentimes don't see, right? They're kind of hidden, those imaginary roots. But if we were to then take those roots and bring them over to the complex plane, we could see all of the roots.
Yeah.
Right. So we would see all 3 cube roots, all 10 tenth roots. We won't always see those in
The graph.
the reals.
Kind of
right?
like my last comment, when you drew that cubic graph, it only crossed the x-axis one time.
One.
But we know if it's x cubed, you have to have three solutions. So
Yes.
2 of those would be imaginary because you can't see
Yep.
it.
Exactly. So if we had done, I'm going to change my color and just show you, right? So if I had done y equals x cubed minus 8, right? We would have said, okay, well, I have a root at 2, right? A real root at 2, and so I can graph it this way. But if I came over here and I said, well, x cubed equals 8, so x is the cube root of 8, and I was to solve that, I would see that I'm going to have a real root at 2. I guess on my scale here, it should be out here, right? So ignore this one. It's out here. I'd have a real root at 2, and then I'm going to have a real root over here and a real root over here, and they're going to be 120 degrees apart.
Okay. Another week. That's awesome. I see some real potential there. My mind is blowing.
Thing is, Kirsty, whether we understand it or not, I think the point that you've made here to think about is that imaginary numbers aren't useless. That actually to do any solutions of the cube root of 8 or the fifth root of 27, you need imaginary numbers, and that's just arithmetic. That's not functions and calculus and everything else. So they're important.
Yeah, and I love the fact, Lee, that the math map is going to help students over time become comfortable with this language. They're going to become familiar with these functions. They're going to become familiar with these graphs, that they can start to see these patterns. And then in their transcendental year where we say, okay, go to town, right, they can explore this and say, oh, I'm going to pull these pieces together because I've been equipped to ask these questions and equipped to hopefully answer those questions. So
Percy, Priscilla's asking, I think this will take some time for anybody to get, but solutions and roots are 2 different things. So when you're saying all solutions, you mean real solutions. Priscilla, you're correct there. Because the imaginary solutions she asked aren't there. I'm guessing you mean on the real axes. So that's why you
well,
go somewhere else.
there's
About
that
solution.
idea. Yeah, so the idea is, right, what are all of the solutions to y equals x squared plus 4, right? And so all the solutions are going to be ordered pairs of real numbers, where if x is 0, y is 4. If x is 1, y is 5, right? If x is -1, y is 5. So when I say all the solutions, I'm saying there's all these ordered pairs that when I put in the x and the corresponding y value, it makes that equation true. Roots are very specific to this case where y equals 0. That's when I'm talking about the roots of my equation. And so that's where we see that, right? That I can look at those roots both graphically where y equals 0, but then I can also look at them as, right, this like the square root or the cube root, right? That's what we're talking about when we solve for that value of x. That's the relationship to the idea of arithmetic roots, right? We're connecting this algebraic idea to this arithmetic idea. So our solutions are ordered pairs, are ordered pairs of real numbers that make the equation y equals x squared plus 4 true. And our roots are specifically the case where y equals 0, and it corresponds to the nth root of that number, right? That's where that other connection comes in. So these ideas historically have been taught in this very disjoint way, but they really are all meaning the same thing. It's just, how are we looking at it? Are we looking at it in a real plane, in an imaginary plane, arithmetically, algebraically, geometrically, right? And so one of the things the math map tries to do is bring all of those, right, examine all of those cases. And it's going to take a few years before the puzzle pieces start to fit together.
So we're about out of time. Andia, did you have any questions for today, or Nicole? We don't want to leave you hanging
I
there.
do have one. I would say I think it's quick, but I'm trying to understand the difference between absolute value and cardinality and scalar and coefficients. Are they in any way related, those two relationships between those four
So
things?
yes. So absolute value, right? When we see that sign, the absolute value, it is always a measure of magnitude.
Mm-hmm.
Okay, so whether we are talking about the distance of a number from 0, for example, -6 is 6 units from 0. That's why it's positive, because distance is always positive. Magnitude is always positive. So, or the distance between two numbers, 2 minus 6, right? They are 4 units apart. Or cardinality, we're talking about what's the magnitude or size of the set. So it's same meaning. Or we see it with complex numbers. We're still talking about distance of a point from 0, but now we have to use the Pythagorean theorem. Or we're talking about when we see that absolute value sign on a matrix, we're still talking about a magnitude. It's a little bit different because we're talking about a magnitude in terms of a parallelogram. So it's a lot harder to see, but it's still describing a magnitude. So those absolute value signs, we think of them as absolute value. It's always a measure of magnitude. So hopefully that helps.
Mm-hmm.
So cardinality is a magnitude. It's just the name we give it for using it with sets. Then scalars and coefficients can be the same number, right? A scalar is just a number that doesn't have direction, right? That is telling us how many of something else. It's scaling something else. Now we can have negative scalars which reverse, but they don't have an inherent direction. All right. So it's always just going to look like a number. When we get into in 1D, it's really hard to differentiate between what's a scalar and a vector. We can talk about them and we can say this is a scalar and this is a vector. But once we get into 2D, right, it becomes clear that vectors have 2 or 3 or 4 components, whereas a scalar will always just be a number. It'll just be a single number that's telling us how many of something. So that's a scalar is describing a number that has magnitude only, whereas a coefficient is telling us about the position that a number or a literal takes. And so a coefficient is always is going with a variable. So it's almost, it pretty much is we're talking about variables, right? But sometimes we'll see that we can be thinking about the 0th power of a variable, which is 1. So we'll talk about a coefficient, even if it looks like the variable is not there. But a coefficient is always going with something else, usually a variable. And so it's talking about the position that number takes. So in the case of let me turn the pen back on. In the case of 3x, for example, all right, 3 is a scalar because it's scaling my x and it doesn't have a direction. And it's also a coefficient because its position is that it is next to a variable. So the words can describe the same number, but they're describing different aspects of that number. Does that help?
I think I'll come back and listen to this a few times, and I think I'll get it. But it sounds like what you're saying in the case of 3x, 3 is both a scalar and a coefficient, but for different reasons.
Yes.
Okay. And
Yeah,
you
they're
said
different.
scalar is related to vectors.
Yeah, so when we think about a vector, remember a vector has magnitude and direction.
Mm-hmm.
A scalar only has magnitude.
Oh. Okay, I have to think through that.
So it's like if I go left half a space, the half is just a scalar. The left is telling me my direction. Is that at all helpful, Kirsty?
Yeah.
Yeah, just remember that if you said I went left half a space, the whole thing is a vector, right?
Mm-hmm.
Unless I said my vector is left 1 space and I only went half, now the half would be the scalar and the vector would be 1 space left.
Gotcha. Okay. Well, I'll listen to that a few times. I'm sure it'll cool. Thank you.
You're welcome. Andy, did you have a question?
Yes, you know me so well. My question comes from Binomials, week 7, page 10. My daughter and I were wrestling through like the log bases, like we understand log base powers in the index and stuff like that, but like seeing the log base of -4, is there ever an instance where the log base can be negative?
It should not be. It should always be really greater than 1. But definitely greater than 0, because 1 is sort of, but you could have a fractional base. But we're almost always going to talk about those bases being greater than 0. In the math map, absolutely. It'll always be greater than 0.
And is there some cool math reason why you can't have a negative base in logs?
No, it just that it can get somewhat.
Would they end up being imaginary numbers if you had a negative base?
Well, not so much that, but if you think about, if you were to think about plotting them, the X, right, and the Y, in your index, you would end up with this flip-flopping, right, idea. So usually when we think about logarithms, we're usually going to think about the power and the base being greater than 0, because it just gives us, there's just some weird things that can start happening when we have negative things. So what we're going to be more interested in is what happens between 0 and 1, at 1, and from 1 on, right? And sometimes it's easier to think about it, looking at the exponential function, because I think that's a little bit clearer for us to envision in our minds what's happening. And then understanding it in the exponential function, coming back to going, okay, well, what happens with that in our logarithmic function? And part of it, I could show you this graphically, right? That if you think about your exponential function for some b, right? Whatever my b is, if it's greater than 1, it's going to look like this, right? It's never going to cross my x-axis. Then my logarithm is always going to be, let me change my color here. My logarithm is always going to be the inverse of that. So if I was to draw my y equals x line and reflect it across to find out what my logarithm looks like, right? So there I see that what I'm comparing here are my let me think. I want to make sure I say this right. But notice I've got like positive bases, positive powers here, and my index could be negative, but my power that I'm putting in is going to be positive. And then your base is usually right is going to be fractional. So that kind of gives us a little bit of a hint as to why we're not going to have negative things happening there. So
Andy,
little
another
bit of
thing
a
you can
hint.
do if it was that question that that got brought up on that page, the defined and undefined, is that where you were thinking about it? It's just practice trying to find numbers that would work, and you'll see it's not easy to do. So like when it was a log of 4 to the negative 16, well, 4 to what power is going to give me negative 16? You're going to
Right.
you're going to run into imaginary numbers and things that don't work so easy.
Yeah, and we also, my daughter noticed that in all the other, like the flashcards and all the other instances that we've seen logs, we've never seen a negative number. And I was like,
That's
oh, hey, way to attend.
That's great. Yeah, I mean it's true. Yeah, because that we're going to say we're not going to look at negative values for B and P when we're talking about logs. So
That was my only question.
all right.
Well, I need to go, but thank you, everybody.
Yes, thank you.
Mhm.
Well, thanks everyone. Have a great week. And I will look forward to coming back and looking at curved lines next week. So we kind of had a little preview with some of Jana's questions this week, right? Talking about our quadratics and whatnot. So we're going to take a closer look at those next week. So I'll see you there.